Okay, this is Unit 11. We're in Similarity and we're looking at similar shapes. It says prove that the quadrilaterals ABCD and PQRS are similar. We can do it in two different ways. We can either show that all the angles are the same, or we can show that all the sides are in the same ratio. Just to show this, we're going to do both. I'm sure isn't it more fun? That's 90, that's 90, that's 130. If you add those all together, what do you get? You're going to get 90, 90, 180, so you're going to get 310. That means this angle here must be 50. I mean, it's quite obvious to see what's going to happen here. And that means this, if that's 50, that's 90, that's 90, that's 130. So we can show all angles are equal in corresponding shapes. That phrase isn't quite right, but hopefully we can see that A equals P, B equals Q, D equals S, and C equals R. Therefore, they are similar. So as I said, I would do it two different ways. So the other way you can do this is show that the sides are in ratio. Hopefully you can see what's going on here. So the 3 and the 4.5 should be in the same ratio, 6 to 9. So let's check and see. So what I'm hoping is that PQ, let's see this if we can. Yeah, you can just about fit it in. PQ over AB, I hope is the same as QR over BC, which is the same as SR over DC, which is the same as PS over AD. So I've picked my equivalent side. So let's do the sums here and see how we go. So PQ is, you can almost see this, yeah, if we do there, 4.5 over 3, hopefully equals 9 over 6, which hopefully equals 10.5 over 7, which is equal to 6 over 4. And if you calculate all of those, they're all 3 over 2, which is 1.5. Therefore, the shapes then are similar. The trapezium, ABCD, and PQRS are similar. Find PS. So PS is this one here, and it's equivalent then to your 5.4. So we can set up our wee ratio then. So what we're timesing this by to get this. So if we do 12.8 over 8, it shouldn't be too awkward a number, I hope. That's 8 over 5, so it gives us 8 over 5, or 1.6. And the best way really to think about this is a scale factor. So it's 1.6. If you times everything by 1.6, then you'll get this one. Therefore, PS is going to be 5.4 times by 1.6. Which I think gives us 8.64. And then hopefully you can see then for DC we're going to go backwards. We're going to divide then by 1.6. And DC then is going to be 21.2 divided by 1.6. And that's then 13.25. Now you can set them up as ratios if you want, and that would be fine. I just think this way nearly makes more sense. So hopefully that's okay. Again, folks, sorry, something's going on with the computer here, so let's just check we're still filming. I think we're still filming, so we're okay. Again, those should both be in centimeters. Alright. Similar triangles. Prove triangles are similar, we need to prove only it's the same thing as before. All the corresponding angles in each triangle are equal, or the corresponding sides in each are in the same ratio. Prove the triangles ABC and PQR are similar. So angle A is the same as P. Angle B is the same as R. Now notice those have been flipped, but they can still be similar. This still keeps going for me here. I'm going to see. Sorry, I'm just having a hassle with the computer. I'm assuming it's just still recording. Angle. So that was B is the same as R, and C is the same as angle Q. Therefore, they are similar. Example 2, we've got to prove that they're similar, so hopefully you can see again that these ones are going to be in kind of race with each other. Now we need to be very slightly careful here because they're being a bit cheeky, I think, in terms of mucking around with these numbers. So our biggest one here is DF, and the biggest one here is GH. So we're hoping that DF over GH is the same as, what's the medium one? DE. 7.2 is the next one, and HI, and then the smallest one is EF over 5.12, which is GI. If this is the case, then they're similar. So we hope that 8.4 over 6.72 equals DE 7.2 all over 5.76 equals 6.4 all over 5.12, and if that's the case, then we're good. So if I do 8.4 divided by 6.72, I get 5 over 4. This bodes well. 7.2 divided by 5.76 is 5 over 4, and then 6.4 divided by 5.12 is 5 over 4. It all equals 5 over 4, therefore they are similar. Alright. Example 3. Find the length AB and the length BC. So again, I hope we can see and kind of set up how this works. These two angles there must be the same as each other. Because these are parallel lines, just be careful with this. It means that this angle here is going to be the same then as this angle here. And it means then that this angle here is going to be the same as this angle here. But hopefully you can see now how this sets up, because it's not quite the same. So I can set up my ratio because of these two sides here. I know the ratio then kind of from wee to big is going to be from 12 then to 16. So you need to multiply by 4 over 3, which I think then is our scale factor to get from here to here. So I do 16 over 12, you see. It gives me then 4 over 3. So my scale factor then is times n by 4 over 3 to get from here to here. Now just being careful about which side's which. We want the length of AB, so that's going to be the 10. So AB then is going to be 10 times by 4 over 3, which gives me 4 over 3, obviously, which is 13 and a third. And then my length BC, and again, so what's that equivalent to? That's equivalent then to the 11, so it's 11 times 4 over 3, which is 44 over 3, which is, I know that, don't I, 14 and 2/3? Yeah. We end up with that. Okay, find the length CD and the length BE. Here's our ratio here. Can you see the small triangle and the big triangle? Sometimes it's nearly better actually drawing these things out so you can see what's going on. But 3.7 and 5.5 or 5.55 are going to give us our scale factor. So that's 3 over 2, which is quite nice. So I'm going to draw out actually the small triangle and the big triangle, and we'll fill in what we know. I feel it sort of helps what's going on. So that's CDE, that's 3.7. Here's a bigger one here, and that's CAB, and that's 5.55. We're timesing then by 3/2 to get from the wee one to the big one, and I know then that that's 6.2. So what do we have? Oops, 6.2 is the wee one. Find the length CD and BE. Goodness. Okay, so to get this one here, I'm going to divide 6.2 by 3/2. Please be nice. Oh, that's not nice at all, so that's 4.13. I'm just a bit nervous that that 6.2 is actually the length then from C to E, but it's not really telling you that if that's the case. It's kind of hard to see what way it's done. Anyway, 4.13 is the length then from C to E, so to find the length then from E to B is going to be 6.2 take away 4.13. Which is 2.06 repeating. So let me see, that means then that EB is 2.06. The length CD is messier again, so it's going to be, I'm going to call this length X, and it's going to be X multiplied by 3/2 equals X plus 1.1. So that's quite messy to work out. I hope you can see then what I've managed to do there. So what have I done? X multiplied, so the wee one here we've called X, and then we know this is X plus 1.1 because this is our wee distance here. And so whatever number it is, once you times it by 1.5, you end up then with that. So that's 1.5x if you want to write it like that. 3/2x equals x plus 1.1. It's actually not too bad whenever you think about it. But take away x from both sides, we'll get half of x is 1.1. And that means x then is going to be 2.2. And so my length then CD is going to be 2.2 centimeters. Next wee bit then, length, area and volume of similar solids. Find the length, area or volume of similar solids given in one ratio. The ratio of the length is A to B. The ratio of the surface areas will be A squared B squared. The ratio of the volumes is A cubed B cubed. If we know the ratio of lengths and so on, know the ratio of areas, and we have that. But the deal is as follows, that if you think two things, I always give the example of the Oscars. I don't know if you've ever seen an Oscar as in the award that you win. So the Oscar looks like this here, and it's a foot tall. It's a wee gold statue on a plinth, and it is 1 foot tall. Once you go, whenever you're going into the Oscars, there's a big massive one. There's on the kind of steps on the way in, and it is 6 foot tall. This is just talking you through the idea of this. So the scale factor here is 1 to 6. Say they're both made out of gold paint, they're painted gold. It's not that you need 6 times more paint for this one than this one. You actually need 36 times more paint because that's the area. So if the heights are in the ratio 1 to 6, then the areas are in the ratio 1 squared to 6 squared. So that's 1 to 36. You need 36 times more paint then to do this to this. If we forget about painting it, but actually thinking about the volume of each one, say each one's made out of solid gold, the volumes are in the ratios then 1 cubed to 6 cubed. So the volumes are actually in the ratio 1 to 216. So you might think, oh yeah, they're in the ratio 1 to 6, which they are for their heights, because this is 1 foot high, this is 6 feet high. However, the volume of it, if you wanted to make one of these out of the same material as this, you actually need 216 times more material to get them from there to there. So that'll hopefully help us, and hopefully you can get your head around that, what it is we're trying to do. Two solids P and Q are similar. The height of P is 3.6, the height of Q is 6.48. The base area of P is 24, the volume of Q is that. Calculate the ratio of the lengths in the simplest form. So 3.6 and 6.48. If I do 6.48 divided by 3.6, it should give me a bit of a clue. It's going to be 9 over 5, but we'll do it whatever way you want, really. So let's go for a 3.6, 6.48. I don't like the decimals in there, so if we go for 360 divided by 648, how would that cancel down? What do they both divide by? They both divide by 12, maybe, I don't know. 648 divided by 12. Yeah, it does. So you divide this by 12, you get 30, and we get 54, for example. They both divide by 6, don't they? So 5 to 9, then are the ratios in that case. Alright, part B, areas, then in ratio will be 5 squared to 9 squared. So they're going to be 25 to 81. If we know the area of P is 24, quite an awkward sum here, but that's okay. If we divide by 25, multiply by 81, so we would need to divide by 25 and multiply by 81. So we're going to go 24 divided by 25 equals multiply by 81, 77.76. That's going to be then centimeters squared. Volume, I'm not sure how nicely this number is going to work out, but the ratio then of volume is going to be 5 cubes, so it's actually going to be 125 to 729, and we know the volume of Q is 8398.08. So how do I get from here to here? I divide by 729 and multiply by 125. Goodness knows how this will go. Divide by 729, multiply by 125. 8398.08 divided by 729. Okay, this is going to work out nicely, I think. Multiply by 125. 1440, and that's the volume then that we're looking for then for C. So hopefully that makes a wee bit of sense. If the lengths are in the ratio 5 to 9, it means the areas are in the ratio 25 to 81, and the volumes are in the ratio 5 cubed to 9 cubed, which is 125 to 179. The capacities of two similar cylinders, C and D, are 216 and 512. I like to look at those numbers. The radius of C is 10.2. Find the radius of D. So volumes are in ratio 216, 512. That means the lengths are in ratio, you've got to find the cube root of 216 and the cube root of 512. Cube root of 216 is a nice number, it is 6. Cube root of 512 is a nice number, it is 8. Cancel that down, so the lengths are in the ratio then 3 to 4, which is quite nice for us. We can now answer part A. The radius of C is 10.2. So remember, C is a smaller one, so 10.2, 102, maybe it does, I think it does. So we are going to, how do you get from here to here? You divide by 3 and you times by 4. So we're going to divide by 3 times by 4. Is it 3.4? Isn't it? 3.4, 6.8, 12, 13.6, is that right? I don't quite trust myself. 10.2 divided by 3 multiplied by 4 13.6. And that is in centimetres. Part B, the curved surface area is 115.2. That's if the D one. Find the curved surface area of C. So we need to work out ratio of areas is going to be 3 squared to 4 squared, which is of course going to be 9 to 16. We're told that the big one then is 115.2. How do we get from 16 to 9? We divide by 16 and we times by 9. So we're going to do the same here. Divide by 16 times by 9. And we end up then with 64.8. So the answer then is 64.8. And that then is centimetres squared. Alright.